Hello and good afternoon. My name is Loveline Julian, and this is our final project for operating system. And our topic that we have chosen is fixed and dynamic memory management, next fit and worst fit. And this project is prepared by Kugan, Aina, Salini, and me, myself, Loveline. Okay, so we introduce a bit about our project. Okay, so this is our title, Fixed and Dynamic Memory Management for Next Fit and Worst Fit. So this is our abstract about the using of memory management strategies, yeah, specifically on next fit and worst fit, in the dynamic environment of parking lot management, with an emphasis on efficiently allocating parking spaces to vehicles of varied size. So next fit uses classic computer system procedure to start allocation from the last slot and progress sequentially, aiming for speedy allocation and reduce search time. Worst fit, on the other hand, assign the most available parking space to arriving vehicles with the goal of maximizing vehicle space utilization while perhaps decreasing fragmentation. Okay, so this is our introduction for operating system, teaching and also learning. So what we have learned during this semester about operating system and our real life application on the using the worst next fit and also worst fit for our parking lot management. Okay, this is our problem statement related works, methodology for our project management flow chart, and so there's no hardware used for this project, but we use software which is Flowchart Maker and online diagram software, and also Microsoft PowerPoint to make an animation of the program. So this is our task distribution and our design and implementation. Next is our result and also discussion. This will be explained more during the animation presentation later on. Okay, so yeah, this is the result. Okay, so next is our future work and also conclusion. Next is also acknowledgement and also references for this project. Okay, that's all from me. Thank you.
Hi everyone. Today I will present how our team collaborated on this project. Our teamwork was a well-coordinated effort, and we each took on specific roles to ensure the project's success. Firstly, Kugan proposed the innovative idea of applying memory management strategies to parking lot management. He was instrumental in compiling and completing the slide presentation and animation video, collaborating closely with Salini. As for my role, Aina Najwa, I was responsible for writing the project report. I drafted key sections, including the abstract, problem statement, related words, design and implementation, and future work and conclusion. Additionally, I included the acknowledgement and references, ensuring our report was comprehensive and well documented. Then, Salini took charge of creating the animation video, which illustrated the concepts of next fit and worst fit in an engaging and informative manner. Her collaboration with Kugan ensured that the animations aligned seamlessly with our slide presentation. Lastly, Loveline handled the introduction and methodology sections of the report, including the flowcharts for project management. She also worked on the results and discussion section, interpreting our findings and adding acknowledgements to the documentation. Her coordination with me was crucial to maintaining the report's thoroughness and organization. Overall, our teamwork was characterized by clear communication and a strategic division of tasks. Regular meetings allow us to discuss progress, share insights, and resolve issues efficiently. Each member's contributions were vital to our project success, demonstrating the power of effective collaboration.
Hello everyone. Today we'll be presenting our operating system group project. So the title for our project will be Fixed and Dynamic Memory Management, and the algorithms that we use for this project is next fit and worst fit. So we'll be looking at the problem statement first. In a large parking lot with a range of parking space sizes and vehicles arriving and departing throughout the day, it is critical to efficiently distribute parking spaces in order to maximize space utilization and reduce search time for vacant places. This research seeks to solve the problem of efficient parking space allocation by implementing two algorithms. So the first algorithm will be next fit and also the worst fit. And in the next slides, we'll be assessing their performance and also determine the optimum solution for various scenarios. The first algorithm that we'll be looking at will be next fit. Okay, first we'll be looking at two things, the definition and also the flow of the algorithm. So first will be the definition. Next fit is a memory allocation strategy utilized in operating systems and computer science to effectively manage memory blocks or storage units. And the flow is that the next fit works similarly as first fit, which is allocating the first hole that is big enough. However, the difference is that the next allocation is done by searching for the next available hole from the last hole it has been allocated, instead of searching from the first hole again, as in the first fit algorithm. Okay, we'll be looking at a simple animation here. So we'll be looking at four parking lots in a parking space with different sizes. So the first vehicle arriving is a car, and we could see that we'll be searching for the first parking lot in this parking space. So it will be parking space A. So we could see that the car parks at space A, and we could look at the description here. The car arrives first and utilizes the next fit strategy by selecting the first available parking space, which is space A. And we could see the next arriving vehicle, which is a motorcycle, and we could see that it will be looking at the next space available after the car has been parked. So it will be space B. So you can see that the motorcycle is parked at space B. So the motorcycle arrives next and utilizes the next fit strategy by selecting the next available parking space after space A, which is space B. The next vehicle we could see here is a lorry, and it will be searching for the next available space here, and in here we could see it will be space C. However, we could see that by visually we could see that space C will not accommodate the lorry, so it will be looking at the next available space, so it will be space D. So we can see that it parks at space D. So the lorry arrives next and utilizes the next fit strategy by selecting the next available parking space after space B, which is space D instead of space C, since it is based on the size factor. Alright, the next vehicle arriving here will be a bus, and we could see that it'll be looking for available space in this parking space. However, we could see that since that all the spaces has been there are no available spaces after space D, so it will not be allocated in any parking space in any parking lots in this parking space. So we could see that the bus will not be allocated at all in this parking space. So in conclusion, space C will be unallocated and will remain free. Thank you.
So now I'll be presenting WordFit. So WordFit is a memory allocation strategy. So it uses the largest available space to coordinate the process of the program. So let's look at the animation to understand it further. So first we have four places with E, B, C and D. So the largest space is B, and then the second largest space is A, third largest space is D, and then the smallest space is C. Okay, as you can see, the lorry arrives first, so we take the largest available space, which is space B. And then the second process, which is the car, when it comes in, we look for the most suitable available place that is the largest. So compared to A, C, and D, so space A is the largest, so we take space A. Then you have the motorcycle. So the motorcycle takes the most largest available space, which is space D. And then you have space C as the remaining space, so that since that's the smallest space, the bus is unable to accommodate for that place. So the bus has to wait for the bigger space to open up for it to be used. Okay, that's all from us. Thank you.